welcome to our week 5 lecture for our CIS 2859 course, Game Software Development. This week we are going to be taking a step back from looking at 3D game development, and we're going to sort of begin to look at 2D game development, right? So we're just going to kind of get an introduction here. And in this lecture, we're actually going to be building a short little 2D game. It's going to be like a memory match game, right? Where you flip cards over and see if they match, basically. So some of the goals of this lecture. So by the end of this lecture, you will be able to understand the difference between 2D and 3D projects, and you'll be able to create a grid of game objects, right? Because we're going to have a grid for our memory match cards. We'll be able to use arrays to manage game data, right? We're going to be doing that for our different cards that we have. And we'll build a complete playable game. A simple game, but still a complete playable game. So, what actually makes a game 2D, right? I'm sure many of you are familiar with the differences between 3D games and 2D games, but just to note the main differences, right? In 3D games, we use the X, Y, and Z coordinates, right? And objects will have depth, and we usually use perspective cameras, right? And in 2D games, we primarily use the X and the Y coordinates, and we don't really use the Z coordinate, except for when we're sort of working with different layers within our game. And we use flat artwork that is called sprites, right? Like the drink. And we often use orthographic cameras, right? So just to touch on sprites versus textures, a sprite is a 2D image that is rendered directly onto the screen, right? So in our 2D game, this could be things like characters, cards like we'll see today, UI icons, and backgrounds. And then a texture would be also a 2D image, right? But it's applied to a 3D model, right? So a wood texture on a table or a brick texture on a wall could be examples there. So what we're going to do is we are going to actually create a 2D project. So I'm going to go ahead and pull up my Unity Hub here. And we're going to create a new project. I'm going to be using Unity 6.4 as per usual. And instead of Universal 3D, we're going to be choosing Universal 2D, okay? And as for our project name here, we can go ahead and change this. Let's just name this Memory Match example is what I'll name it. And then just make sure you're saving it where you want it to be saved. So I would like mine to be saved under here, and we'll create a new folder. This is lecture 5, and we will just call it intro to 2D. Okay. And that's the folder we're going to go ahead and save our project into. So make sure that you've named your project what you'd like to name it, and make sure it is stored in a location that you would like. And once you choose those two, those are the ones that matter. Again, pick Universal 2D instead of Universal 3D. And we can go ahead and click Create Project. And it is going to begin creating the project. And, you'll see the classic Unity engine pop up. Mine's on my other screen. But I'm going to go ahead and pause the video here. Go ahead and create your project as well. And then I will jump back over once the project has finished creating. Alrighty, everyone. So I am now loaded into my game. You can see I'm in editor here. Hopefully you are also loaded into your project. And the first thing that I sort of want to do is take a look at the camera, actually, because the camera is set to a different projection, right? So in our 3D games, we've been using perspective camera, but in our 2D games, we'll be using orthographic camera projection. And the reason I just wanted to touch on it is to understand the difference between the two a little bit, right? So perspective camera makes the objects that are farther away appear smaller, right? Which is super handy in 3D games because we're working within a 3D world. But with our orthographic camera, what it does is it makes objects remain the same size regardless of the distance, right? So for instance, if I wanted to just create like a little square here, you can see that right now we are not, we're at 0 on the z-axis. And then if I actually move the square closer, well, you can see it disappears at a certain point, and that point would be -10. And you can see, though, if we sort of keep having z go up on the, um, or if we keep having the value go up on the z-axis, it doesn't actually change, right? Our square looks the same. The only reason the square disappears at some point is because our camera is actually at -10 on the z-axis, right? So it's basically, if we look at it like this, right? So if we pop into 3D, you can see that our camera is sitting at -10, and then it's just extending all the way back, right? And we can see everything within the square. And you might get a better idea here if I click on the square. You can see that I'm moving it closer and further away from the camera right here. But you can see in my game view down here that it doesn't actually change. Okay, so this is sort of the draw of the orthographic camera projection. If we change to perspective, you can see that we kind of have this perspective lens now. And as we begin to move the square here, the square sprite, you can see that it does get closer and farther away when we move it, which is not what we want in a 2D game normally. So I'm going to switch it back to orthographic and go ahead and delete the square because we don't need those. I just wanted to showcase that. I'm also going to pop back into 2D mode. I just use this 2D button at the top to go in and out of 2D view. But what we're going to be doing is we're going to be building a memory game. Okay. So some of the features that we're going to want in this memory game, right? We want to be able to click on the cards, right? When we click on the cards, we want them to flip over and kind of show what they are. We need to have some sort of matching system, right? Because we want to be able to detect when two cards are the same, right? So we need to be able to detect that, and we need to detect when two cards are not the same. And then just little things that we also may want. We also probably want to keep track of some sort of score, right, as the game progresses. And we can add in a restart button so that once the game has been completed, we can click restart and it will go ahead and restart the game, right? So the first thing we need to do is import assets, okay? And I've provided some assets on D2L in a zip folder that you can go ahead and download. I've already extracted the assets. So I actually have them pulled up right here. So as you can see, they're already extracted, but go ahead and download that, save it to a place you'd like, and then extract the zip folder. And then we're going to import the assets. And literally all you have to do is click on it in the File Explorer, and you can drag over to Unity, and it will go ahead and import the assets for you. And then once it's in, we'll just double click to make sure they're all here. They are. You can see we've got a card back here. So this will be the back of our cards. We have 4 different card types, right? A square, heart, diamond, and crescent. We have a start button, and we have a tabletop, right? For kind of the background of our game here. So the very first thing that we're going to actually do is create this background for our game. So we can grab tabletop right here, and we can go ahead and click and drag it. I'm just going to click it into the hierarchy, and it will auto place it here for us. And you'll notice that it's a little bit small. So we'll set the position to 005 just to sort of distinguish it and push it a little bit further back from the camera. Because remember, we're going to have things that go on top of the background, right? Like our cards. And this is actually going to be our play surface and our background of the game. So I'm going to go ahead and extend this background sort of to just cover this entire area. So that way we have this as our backdrop. If we go ahead and set this back to 0, and then it looks like about 1.75 here should do the trick. And then about 1.35 should fill it in nicely. It will overlap a little bit with the camera, but that's totally fine. As you can see, it goes a little bit outside the lines of the camera, but that's not important because we can't see outside the camera anyway. So we've got that set up. If you get annoyed by these are called gizmos, these icons here. If you get annoyed by them, I tend to, if you go to the top and click this far right option, it actually turns off gizmos. It does turn off the camera outline, unfortunately, but if you click the drop down, you can select which gizmos you want. You can sort of like edit the size and the fade on them. So it's pretty handy to take a look at if any of those are bothering you. So now we've got our background. I am actually going to rename this to be background. Perfect. And that works right there. Now what we're going to be doing is we're going to be designing our card prefab. Okay, so what we're going to do is we're going to grab one of our card fronts. In this case, we'll just grab the crescent symbol, right? So this is the front of our card. And what we're going to do is we're going to set its position to -3 and then 1 on the Y and 0 on the Z. And then what we're going to do is we're going to drag in card back and we're going to make it a child of card front. Okay. And what we need to do here is we need to make sure its position on the X and the Y are set to 0, 0. And then we want it to be on the Z -0.1, right? And you'll notice what this does is it brings the back of the card in front of the front of the card, right? And so what this is going to do, it's going to end up doing in the code is we'll end up disabling this game object, this card back game object. And you can see when we disable it, it reveals the front like it's flipping the card over. And then we can flip it back over and the card back is showing again. So that's kind of the idea of what we're going for here. And here also just some other things that our card needs. So I am going to rename crescent symbol here just to be, I'm going to call it card front instead, just to sort of make this a little bit nicer. And then we can change this to say just card back. Just because we're going to be turning this into a prefab, it makes a little bit more sense. But here, what we're going to do now is we need to add a couple components. We're going to grab a box collider 2D, right? 2D because we are working in a 2D game. If you click on this little icon next to edit collider, we can see the collider bounds here, and it looks like our collider does go around the card properly here. You can click on the green little boxes to resize the collider if you need, but mine is good here, so I'm going to leave it. So we can click that again to turn that off. And then we also are going to need a script. So I'm going to go into assets and create a scripts folder. And inside of this folder, once it is done loading, we're going to create a mono behavior script. And this script is going to be called memory card. And I'm just going to let that compile really quick. And this memory card script is going to get attached to our card front. Okay. And the reason we're going to sort of make this entire object into a prefab is because we want to be able to reuse it, right? So we want we're going to have 2 rows with 4 columns each. Okay. And so we're going to want to reuse this same prefab here 8 times, right? Because we'll have 8 different cards on the screen. So now that that's compiled, we can go ahead and click and drag and attach this. I'm going to attach it at the top here just because I like to have my scripts towards the top so I can see them easier. And I believe that is all that we will need, at least for now. You should have a memory card script, a sprite renderer, and a box collider 2D. Okay, and we can go ahead and create our prefabs folder now, because this is where we're going to drag in our card front. And now we have a prefab for our memory card that we can use. Okay, so I'll leave this in the scene for now. But once we start instantiating the cards, in fact, I'll delete this. Actually, since we have the prefab, there's no need. And we're actually going to get right into some scripting. So go ahead and open up memory card. and it may take a moment to load up. That is totally fine. And we are going to work towards instantiating our different cards, right? So first thing I'm going to do is get rid of start and update, because that's just something that I like to do. It's not necessary, but it's kind of what I do when I create a new script. We're going to create a serialized field, right? If you remember, what serialized field does is it allows us to see our field within the inspector and go ahead and change it in the inspector. So this is going to be a private variable, and it is going to be a sprite, and we will just name it image, okay? And this sprite image is going to basically be our reference for the different pictures that we can have on our cards. And then the other thing we need is we're going to say public int, and then we're going to call it ID, but with a capital I. Because we're going to be giving it a getter and a setter. It's going to have a get and a private set. And we're going to use this property in order to give our different memory cards their own unique ID. And this ID is how we're actually going to compare the cards when we write our matching functionality. Okay. So once you have those two at the top, what we can do is we can set up our set card method. Okay. So this is going to be a public method. It'll be a public void because we're not returning anything, and we will call it set card. And it needs to take in a couple parameters, right? It needs to take in an int ID, right? And it needs to take in a sprite image, okay? And we can open and close curly braces here. And we're literally just going to say ID is equal to ID, right? So capital I ID is equal to ID, the ID that was passed in as an argument. And then the other thing we need to do is we need to get component, and we're going to be getting the sprite renderer. And we're going to say dot sprite because we need the sprite itself. And that will be assigned, the sprite in the sprite renderer will be assigned the image that is passed in, right? And this is how we're going to set up our different cards. So we're going to use this method, the set card method, to pass in both an ID for the card and an image for the card to show on the card front. Okay. And then the other thing we need to do that we can set up right now is our detection of our player clicks. Okay. And there's a couple ways that we can do this. One of the ways that's kind of the classic way is using on mouse down, right? So basically what that does is when the mouse button gets pushed down, that's when on mouse down is called. The other way, which would probably be favored in more modern games, but it's a little bit more complex, so we're just going to use on mouse down today, would be to use the new input system and raycasting in order to send a raycast wherever the mouse was clicked. And then you would check to see if the raycast hit something and if it was the right thing and everything. That's a little bit more complex, so we're not going to do it today, but that is an option. And if you wanted to mess around with that and do that yourself, you could do that as well. But for now, we're just going to say public void on mouse down. Oops, it already auto-generated for me, which is good. And then for right now, all we're going to say is debug.log, and we're going to say card clicked. Okay. And then make sure you put a semicolon at the end. Okay. And I did not spell clicked correctly, so that looks funny. But at this point, if we go back into Unity, I guess I should have left the prefab here. So I'm going to have to re-add that to my scene. But if we go ahead and click and drag this in here, you can see that the image is empty for right now, which will probably cause an error here, but we may be able to see our debug.log even with the error. But if we go ahead and click, you can see it tells us that our card has been clicked and it's going up, which is perfect, right? But what do we want to do, remember, when we go ahead and actually when we actually click our object, right? We want the card to flip, right? Quote unquote flip, because all we're really doing behind the scenes is disabling a game object to make it appear that it's flipping. So what we need to do is we need to hide the back of the card to simulate flipping. Okay. So what we're going to do at the top is we are going to create another serialized field here. Oops, it's not going to be a private sprite. It is going to be a private game object, and we will call this card back, and we'll assign this in the inspector. And then what we're going to do is inside of on mouse down, we're going to create an if statement and open and close curly braces here. And then our condition for the if statement will be card back dot active self. Okay. And then right here, we'll say card back dot set active false. Okay. So basically what we're checking here is if the card back is active, right? So if this is true, the card back is active, then we want to set the card back to false, right? Because we've clicked the card, we want to reveal what it is. And then obviously if the card back is false, well, then that means we don't need to do the code in here because it's already set to false. So now we'll be able to actually flip our cards. So if I go into Unity here, and if we see here the card back, let me go ahead and click and drag the card back into card back. And again, remember, you want to go to overrides here and hit apply all. So this is applied to the prefab. And what we can do here is we can set the position here to 0, 0. It doesn't matter for now because it'll get overwritten. When we instantiate everything, it'll go ahead and put it at the proper positions. So now if we run the game, hopefully we should be able to actually flip our cards and see the card back disappear. So, oops, there we go. So if we go ahead and click, you can see that the card back gets disabled and it reveals the front of the card. It took a second to load there, which is why it didn't seem to work the first time I clicked. Cool, so that is working properly. Now what we are going to do, we'll be coming back to this script, this memory card script. But we want to go and start working on another script that we're going to be using. And we'll also need to create an empty game object. And that's going to be the scene controller. Okay. And what the scene controller will do, another word for this you might want to use is game manager. But it's going to manage the whole game, right? So game manager is another good name for it. But basically in here, what we're going to do is we're going to store all the possible card images. We're going to create the grid of cards. We'll assign each card an ID and an image, right? So the image is what we actually see on the card front. The ID is how we check to see if the cards are matching. We need to keep track of the first and second revealed card, right? Because we're trying to match those two. And then we need to check if they're the same. And we'll be able to update the score as well and restart the game. So if I go ahead and right click in the hierarchy and create empty here, I'm going to rename this to be scene controller. And I'm going to go ahead and reset the transform as well. And I am actually going to put an underscore at the front because I do like to put my managers, for my managers and controllers, I like to have an underscore at the front. And then I like to put them towards the top here so I know where they all are. And then what we're going to do is create a new script. And this script is going to be called scene controller. And you can go ahead and let that compile. Once it's all compiled and everything, we're going to attach it to our scene controller object. So it looks like it's all done compiling there. Let's go ahead and click and drag it onto our object and save. And now we can double click to open it. And we're going to begin doing some scripting. So I'm going to remove start and update. And then we're going to need a couple of serialized fields. So I'm going to go ahead and create these. The first one will be a private memory card. And this is going to be the card prefab, okay? And we're going to use this to instantiate our game objects. And then we'll have another serialized field here. This one's going to be a private, and it's going to be a sprite array, okay? And the way we show an array is by putting these square brackets next to the type, the data type, okay? And we're going to call our array card images. And so what this array is going to hold is it will hold all of our different faces, right? So we have a square, a diamond, a crescent, and I forget what the other one is. It might be a triangle. Um, maybe I will see in a second here. A heart, square, diamond, and crescent, right? So those are our different actual cards. And while we're in here, we might as well assign these different things. So we can assign the card prefab here. Make sure when you assign the prefab, you click and drag it from your prefab in the project view. You don't click and drag it from the scene. Otherwise, it will assign this specific instance of the prefab instead of the prefab itself. Okay. And then for card images, we're going to need to populate this list. So we can hit the plus icon 4 times. And if we go over here, we can click and drag crescent, diamond, heart, and square over. Awesome. Let's go ahead and save that and head back into our code here. We're going to need some other serialized fields here, and this is going to have to do with our grid generation. So what I'm going to do is I'm going to type serialized field here, and I'm just going to copy and paste this a few times because it's kind of annoying to retype. Our first one that we need is a private int, and this is going to be called rows, and we want 2 rows if you'll remember. The other thing we need here is a private int columns, and we want 4 columns, right? So 2 rows of 4 columns is going to be 8 cards, so we'll have 4 pairs in our game. And then we want 2 private variables. These will both be floats. One is called x spacing and will be given 2f as the value. And the other one is a private float called y spacing. And we are going to use 2.5f as the value here. And this is just going to be, these two are going to be our spacing basically for our cards. So just making sure that the cards aren't like right next to each other or on top of each other. Okay. X spacing is obviously the horizontal distance between the cards. Y spacing would be the vertical distance between the cards. And then now what we can do is we are going to need start. So I'll regenerate that. And before I type in there, we'll create a method that we're going to call in start. It's going to be a private void called create cards. It can be private because we're only going to call it in this script. And basically, we're going to create a variable. It's going to be an int array called card IDs. And we will go ahead and assign these IDs. It's going to be 0, 0, 1, 1, 2, 2, and 3, 3. Okay, so these are going to be our different IDs and our different matching pairs, right? So we have those, and we're going to call create cards here in start. Awesome. So now our cards, we have our array that's storing each of the IDs, right? So 2 zeros, 2 ones, 2 twos, and 2 threes. Okay. And you may be wondering why we're using IDs instead of comparing the sprites. Comparing IDs is just a little bit cleaner than comparing the sprites, right? So think of it as instead of asking, do these 2 cards have the exact same image? Think of, do these 2 cards have the same ID, which is a lot easier to check. So that's kind of the reasoning behind giving each card an ID. And now we are going to continue working in our create cards method here. So before we actually place the cards down, we need to shuffle their IDs, right? Right now, the IDs are just right next to each other. So it would be very easy, right? 0 and 0 next to each other, 1 and 1 are next to each other, 2 and 2 are next to each other, 3 and 3 are next to each other. We want it to be randomly placed, right? So what we're going to do is we're going to hit enter a couple times, and we're going to say card IDs equals, and then we're going to call a method that we haven't written yet, but it's going to be called shuffle array. And we will pass in card IDs. And this is going to give you an error. That's okay. We are going to fix the error in a moment here. But another thing to note is that we don't want to use random.range here, okay? And the reason for that is it can create uneven cards, right? So if we used random.range and tried to shuffle it that way, then and it was like between 0 and the length of card IDs or something like that, then we might end up with like 3 zeros in the mix and only 1 1, and it could get messy. So we want to write our own shuffle array method that's going to properly shuffle the array here for us. And then what we're going to do, just finishing up create cards here before we go to shuffle array, we need to loop through our grid and get ready to start placing our cards. So we're going to use some nested for loops. The first one, we're going to say for int row equals 0. And then we're going to say row is less than rows. Okay, if you'll remember, row is the variable that we've just created right here. Think of it as I. And then, in fact, it may be easier to understand if you use I and J instead of row and call, but I'm going to use row and call for this example. Rows, remember, is our variable up here, our field up here, and columns, when we get to it, is our field up here. So row is less than rows, and then we'll say row plus plus. Okay. So what this is going to do is it's going to loop through our rows. So we're going to start at 0. 0 is less than 2. So we are going to do the stuff in the for loop and then increment row. Row is now equal to 1. 1 is less than 2. So we'll do the stuff in the for loop and then we'll increment row. Now row is equal to 2. 2 is not less than 2, so we'll break out of the for loop, right? So that's the basic idea behind it. And we need to do the same thing for our columns, right? So we'll say int call equals 0, and then we'll say call is less than columns, and then we'll say call plus plus. Now, obviously, the inner for loop will run a couple more times because we have 4 columns, right, and only 2 rows. So the number that we're checking for columns is 4, and for rows is 2. But what we're doing here with this nested for loop is, so what'll happen is for int row is equal to 0. 0 is less than 2, which is perfect. So we'll do the stuff in the for loop. And what we need to do in the for loop is loop through this for loop, 4 times until we break out of this for loop. And then once we break out of this for loop, we'll break out of the other for loop and row will get incremented. And then row will be 1, and then we'll do the same thing again, right? So basically just using 2 loops nested together to loop through different rows and columns. And then we are going to do something that might seem complex when you first read it, but hopefully I can explain it in a way that makes sense. We're going to say int index is equal to row times columns and then plus call. Okay. And what we're doing here, right, is we are working with a 2D board in our game, right? So we have rows and columns on our board. The thing to think about is that our array up here is one-dimensional, right? So for our indices, right, these are our values of our array, but our indices are actually 0, 1, 2, 3, 4, 5, 6, 7, right? So those are the indices and they're one-dimensional. So we need to convert this one-dimensional array into a format that makes sense for our 2-dimensional grid that we're creating. And I tried to explain it on the slides here just to pull it up. So we're working with the 2D board. So this shows row 0 and this is row 1 right here. And actually maybe I should use the pen here just to show. But we're working with row 0 and row 1. And then I've tried to sort of designate the columns here where, this is the 0 column, the 1 column, 2 column, and 3 column. And what we're doing is we are saying row times column, so 2 times 4, and then plus call, right? Well, technically it wouldn't be 2 times 4 initially. So if I go back to the game, just to sort of look at it. So row is equal to 0 first, and column is also equal to 0 first. So if we go to our slides, row is equal to 0, and columns is equal to 0. So 0 times 0 is 0, plus call. So call is equal to if we go back to the game here and we take a look, row is, or excuse me, it's row times columns plus call, right? So it's 0 times 4, and then plus call, which call is equal to 0 initially. So in the slides, if we come here, then 0 times 4 is 0, plus 0 is 0. So we have 0 right here. And then we just kind of continue from there, right? So row is still going to be equal to 0 times columns, right? Columns is 4, so that's 0 again, but plus call has been incremented, so it's 1. So what you end up seeing is we have 0, 1, 2, 3, okay? And then once we get to row 1, now we have 1 times columns, right? Because we've incremented row. We have 1 times 4, so that's 4 plus call 0. So we end up getting 4 here, and then 5, and then 6, and then 7, right? And so what you see is that these different indexes or indices actually align with our indices down here, right? We have 0 through 7, and now we've sort of put the split in the middle where we can see that this over here is our 0, and this over here is our 1. So hopefully that makes sense why we're doing that. I will go ahead and erase everything from the slide there. But hopefully that makes sense why we're doing this. So we're basically just making it so that our 1D array right here translates into a 2D grid. Okay. So now that we have written that line of code here, if I go ahead and slide on over, trying to go to the next slide, but it's being annoying. Oh, it's because I'm not on my, there we go. Okay. Sorry, I had to reset that. So now that we've done that, we can actually go to the lines below it, and we can say memory card, and then we're going to name this variable new card, and we are going to instantiate our card prefab. Okay. So now that we've done that, we can go ahead and instantiate our card prefab. I spelled instantiate wrong, which is why it's angry. So we're instantiating our card prefab, and then underneath that, we also want a int card ID. This is another variable we're going to use, and we're going to set it equal to card IDs, and we want to do it at index. Okay. Oops. Don't mind me while I mess up typing. So you can see here, we're creating our new card based on our card prefab, and then the card ID, which we're going to assign to our new card, is going to be card IDs at index. And if you remember, right, we shuffle the array first. So when we start, our first index is going to be 0, right? Because row 0 times columns 4 is 0, plus call, which is 0, is 0 altogether. So index is equal to 0. So card ID is going to be equal to card IDs at index 0. And it won't necessarily be 0. It could be 0. But because we're shuffling our array before we do all this, we could have 1. It could be 2. It could be 3. It could be 0. So it could be any of those. So after we do all this, this is when we're going to call our set card method. Okay. And we're going to say new card dot set card. Okay. And if you remember from when we wrote this method earlier, we need to pass in a card ID, right? Which is the card ID we just created here and stored in this variable. So now we've randomized the card ID, and we also want to go ahead and associate the image with the proper. We want the proper image to be on our card, right? So again, we say card images at card ID. And that's because if we go ahead and take a look at card images here, we have an array of sprites, right? Remember, we assigned it in the inspector. So at the card ID, the card images is going to assign it, right? So let's say, for instance, we've mixed it up. So let's say that our index is 2 here, okay? So card ID has been assigned the value 2. And when we call set card, we set the card ID to 2 and we set the card image to 2. So what this does in Unity is if you look at our card images array here, it actually shows you the elements as well. That means that our card will be assigned the heart symbol because that is at element 2, okay? So that is what we are doing here, is just making sure the IDs is the same as the image that is displayed to the user, okay? And then we want to position our cards. So we can go ahead and enter a couple times. We'll need a float x pause, and we're going to set that equal to call times x spacing, okay? And we're using column for the x spacing because columns go left to right, right? And rows go up and down. So we're going to use y spacing for the rows here. So if we say float y pause is equal to row times, and then we actually want to multiply it by negative y spacing, okay? And the reason we want to do negative y spacing is because we want our row to be generated below, right? We don't want to generate the row above. And then just underneath this, we can say new card dot transform dot position is equal to a new vector 3, and we will pass in x pause, y pause, and 0 because the z doesn't really matter for us here. And then before we head back and take a look at all this, we need to create our shuffle array method. So this is going to be a new method here that we haven't made yet. It's going to be a private int array. So it's going to return an int array, and it's going to be called shuffle array. Okay, and it will take in a int array, and we'll call this numbers. We can open and close curly braces here. And inside of here, we want to say int array new array is equal to numbers clone. And then we're going to say as int array, just so it clones it as an int array. And what we're doing here is we're just making a clone of our array. So we have two basically copies of the array. We have our initial one we pass in, numbers, and we have a cloned one called new array. And what we're basically going to be doing here is inside of a for loop, we're going to be sort of switching around and changing the order of things. So we're going to say for, and then we'll say int I equals 0. And while I is less than new array dot length, and then we'll say I plus plus, okay? And then we'll open and close curly braces. So as long as I is less than the length of the array, then we're going to continue to sort of mix up the array numbers here. We're going to need a couple of variables. So the first one is int temp. This is going to be a just a temporary one, and it's going to be set equal to new array at I, okay? And then we're also going to have int random index, and this is going to be a random.range, and the range is going to be between I and the new array dot length, okay? And go ahead and put a semicolon there. And then underneath this, we'll say new array at I is equal to new array at random index. Oops. And then we're also going to say new array at random index is equal to temp. Okay, and then underneath the for loop, we need to return new array here. All right. So what we're doing here inside of the for loop is kind of important, right? So we should take a look at it and just make sure you understand what's happening here. So we are looping through the entire length of the array here. And then what int temp equals new array at I is doing is we're saving the current value, right? So the current value, so I is equal to 0 right now. So this is the same as saying, so our temp variable is going to hold the value 0 in it, okay? And then what we're going to be doing that after that is we're going to pick a random position, right? So that's our random index here. And we're using random.range to go between I and new array.length, right? So I is 0 and new array.length is, well, the new array will be 8, right? That's technically the length here. So let's say that this picks 5. That means that we're going to swap our index with we're setting our random index equal to 5 right there, okay? And then what we're going to end up doing is swapping our random or swapping our index 0 with index 5, right? So then what we have to actually do is we have to actually swap it, okay? So right here, we say new array at I, so at 0, is equal to new array at random index. So we're saying that instead of pointing to index 0, we're going to be pointing to index 5, okay? And then now that new array at I, so at 0 is actually new array at 5, well, new array at random index is also at 5. We need that one to point to 0 because we're basically swapping the values here. So new array at random index is now equal to temp, and you can see where temp comes back into play here. So basically how this is working is we're just for the first pass here to go through the first pass, and then you can kind of see how the rest goes through. So new array at I is 0, so temp is equal to 0. Random index gets set to 5 in this example. And then what we're doing is setting our new array at index I, which was previously 0. It's now going to be 5, right? And then our new array at random index is going to be equal to temp, which was storing 0 for us, and will now be 0. So probably the best way to visualize this would be if I just write a quick comment here. So imagine this is our array here. And initially we had 0, 0, 1, 1, or 1, 2, 2, and 3, 3. So what we're doing is we are taking our index right here, so 0, and we're swapping it with 5, right? So 0, 1, 2, 3, 4. So what happens here is we actually swap with the, well, first what happens is the 0 becomes 2. So that's what happens right here is we actually swap our new array at I, so at index 0, to be new array at random index. So it's actually pointing towards 2 now. And then we need to change this back to 0, which is what we're doing with our temp, and why we're even using a temp variable, because otherwise we'd overwrite. Right here, we'd be overwriting our new array at I, so we would lose this value. We wouldn't know what this value is. So temp keeps track of the value and then gets assigned at the end here. And by doing this, and then, that's only one pass at it. So then I gets incremented to 1, and then the same thing happens. And then we end up shuffling the array up, right? So it could be something like, we'll go through a couple more passes here. So I is equal to 1. So temp is now equal to 1. And then random index, we'll say that the random range it'll be between 1 and new array.length. We'll say it is 2 this time, okay? So new array at I, so at 1 is, so this is at 1, is now equal to new array at random index, which is 2. So this is going to become 1 now. And then what we need to do is set our new array at random index. So at 2 equal to temp, and temp was 0. So we end up swapping these around. And then you can see as we continue to make these passes, our array ends up getting shuffled up, and we end up with our shuffled array, and things are nice and pretty for us. So that way our cards are not right next to each other. Okay. So hopefully that makes sense. It's a little bit more complex. But hopefully you kind of understand it with the visual. And yeah, so that is how we're shuffling up our array and then able to use that shuffled array here to spawn in our grid. So now that this is saved, if we go into Unity, let's go ahead and delete this prefab here. Let me make sure there's no overrides. There isn't. And then if we save the scene and hit scene controller, just want to make sure everything is filled in. It looks like it is, so we can hit play. And hopefully we should see that things get filled out for us here. Yep. So you can see that it actually spawns everything in for us here. You can see it's a little bit off center here, but that's okay. And we can actually flip these and you can see that, well, they don't flip back over, but you can see that everything got mixed up a bit. So square is element 3. So you can see that this should be crescent, crescent, diamond, diamond, heart, heart, square, square. Okay. And instead of crescent, crescent, we have square, diamond. Instead of diamond, diamond, this diamond stayed in the same spot inevitably, but there's no diamond here anymore. Neither heart is here and neither square is here. So our shuffling and everything is working properly. And if you wanted to, I'm not going to sort of fix the off-centeredness of it, just because in the slides, that's how I made it. But if you wanted to, you could fix the spacing between, well, this spacing would be the spacing between different cards. But the reason is because the first one spawns at 0, 0. So if we go to our prefab, I can show you what you would do here. So clicking and dragging this in, we probably want it to be, well, I don't want to click and drag it in. I want to actually edit it in the prefab view. So let's see here. We probably -3, 1 should be enough, but let's double check here. It is setting it to 0 or to weird numbers here, weirdly enough. Let's see if we change this to -3 and 1. It doesn't have any overrides there. Let me just I'm going to make sure you have it in the scene here, your prefab still, but I'm going to delete the prefab here. And then if you right click, go to prefab and you unpack, then it will no longer be a prefab. And then we can go ahead and click and drag and recreate the prefab down here. I just want to make sure that it's set up properly. And then make sure you click and drag the prefab back in over here on the scene controller and hit save. And then play again and we'll see how this looks. When I initially made this, let's see. Yeah, it's still generating down there. I would have to look into it. I'm not going to look into it right now. When I initially made this, it was on a way different Unity version. So it might be just something that's a little bit off. But I'm not going to look into it right now. Feel free to look into it on your own if you don't like that it's off-centered. But it's not a major deal to me. You can also adjust the camera if you wanted to. That's another thing you could do. But now that we have our shuffling set up, we can actually head back to memory card and make some changes in here. So we do need a reference to the scene controller. So I am going to create a private variable here. And this is just going to be a private scene controller, and we're going to call it scene controller. And then we're going to create another setter method here. We're going to call it public void, and it's going to be called set controller. And then it takes in a scene controller. And then inside of here, we just say controller. Excuse me, we want this variable up here to just be called controller. And then we'll say controller is equal to scene controller. Okay. And then if we go into scene controller after we have created our card, so I'm just looking here. So at the end here, after we have created our individual card, we can say right here, new card is our dot set controller. and we're sending controller to this. Okay. And make sure you're doing it inside of the for loop, so it's happening for each of the cards. Okay. And you won't actually be able to access new card unless you're in the correct for loop. So that is set up, and then we can pop, we're already in sync controller, but at the top here, we need to keep track of which memory cards get revealed, right? So if we go ahead and double click enter here and type private memory card, and we'll call this first revealed. And then we need a private memory card, and we'll call it second revealed. And then we need a method that we'll create down at the bottom here. It's going to be a public bool called can reveal that helps us know if we're able to reveal. Actually, this is going to be a variable here, or a property. So I'm going to scroll up, and up here at the top, this is going to be a property public bool can reveal. And then just we're going to create our getter here. And inside of the get, we will return second revealed is equal to null. Okay. And what this does, make sure you close the curly brace here. What this is going to do for us is it will let us know if we're able to continue revealing cards, right? So if the second revealed variable we have, so if it's equal to null, that means that we haven't revealed the second card. Well, that's good. Then we're able to reveal cards, right? So second revealed is equal to null will return true, which means we can reveal. If second revealed has, if we flip two cards, second revealed will not be equal to null, so it'll return false, which means we can't reveal any other cards. Okay, so that's the goal of using can reveal here. And then inside of memory card here, if we go to on mouse down, we need to make some changes. So not only checking the active self here, but also use the double ampersand for the and symbol. We're also checking to see if controller dot can reveal. Okay, so now we are checking to see if we're actually able to reveal the card. So, and then another line inside of here is we'll need to say controller dot card revealed, and we will say this, right? This card has been revealed. And we actually need to create card revealed here. This is going to be a method within our scene controller. So I'm going to scroll down and create a new method here. It's going to be a public method, so we can use it in memory card, a public void card revealed. And we are going to pass in a memory card, and inside of here, we're going to have an if statement. So we're going to say if first revealed is equal to null, right? So that means if we haven't flipped over a card yet, basically, then first revealed is going to be equal to the card that gets passed in. Okay. Else, right? The other alternative would be that the second card basically needs to be revealed. So the first one's been revealed, so we are revealing the second card. So we'll say second revealed equals card. And then we're going to start a coroutine, which again, we haven't written this yet, but that's okay. And this coroutine is going to be called check match. Okay, and this coroutine is going to handle actually checking to see if our cards match. And you may be wondering, why are we using a coroutine here instead of just like writing some code or making it a method? The reason for that is if our cards don't match, we don't want them to be hidden instantly, right? So if we just wrote code to flip them back over, then they would immediately get flipped over and the player wouldn't be able to look at them. But we want to give the player a chance to memorize what the cards were. So basically, coroutines are going to allow us to wait before continuing. So let's go ahead and write this coroutine here. It's going to be a private IE numerator, and we are going to call it check match, right? And we can go ahead and open and close curly braces here. So the first thing we need to do in here is we need to check if the first revealed dot ID is equal to the second reveal dot ID, right? So we're checking to see if the IDs are the same of the two cards. If they are, then we can say score plus plus. We have not created this score variable yet, so don't worry about it too much. It will be an error. We'll fix all the errors, don't worry. We're also going to say score label dot text, and we are going to set it equal to, and we're going to use string interpolation here. So we're going to say score colon and then open and close curly braces, and in the curly braces, our score variable that has yet to be created. Don't worry, we're going to be adding that in a moment, in a little here. So cool. So that's what we're doing. So if the IDs match, we increase our score and we update the score text. Otherwise, that means that our IDs did not match. So basically the cards are not the same, right? So we want to yield return a new wait for seconds to give the player time to look at it. And we'll just give them half a second, not super long. So we don't want to make it too easy to memorize. And then after that half of a second, we are basically just going to call first revealed dot hide card. Again, a method we're going to write in a moment here. And we'll call second revealed dot hide card as well. And this is again just going to flip the card back over here. And then after we do all this, we want first revealed to be set equal to null again. And we want the same thing for second revealed, where it's set to null again. So we have a couple of errors we need to fix, right? So we need a hide card method. This can be in memory card. And we are going to go ahead and at the bottom do this. We're going to say public void hide card. And then we are going to say card back dot set active to true. So we're just re-enabling the back of the cards, basically making them flip over. So you can see now that these errors should be fixed. Memory card does not contain a definition. Okay, there we go. It fixed itself. And then the other thing we need to do is we need to actually create the score stuff, right? So that can be in scene controller here. At the top, we will need to add a using statement using TM Pro. And then what we need to do is we need another serialized field here. I'm going to create this one right here. And this is going to be a private TMP underscore text, and it'll be score label. Okay. So right here, you can see we have score label set up. And then the other thing that we need to do is set up score, and score is super simple. We can just do a private variable here. We're just going to say private int score is equal to 0, right? It's just going to start at 0 and it will get incremented. So all of our errors should be gone now, which is perfect. Let's go ahead and create this UI within the Unity editor. So if I go over here and go down to UI and I choose Text Mesh Pro here, we are going to rename this to score text. Oops, it wasn't renaming there, score text. Perfect. And you'll notice it automatically creates the canvas and event system for us. And the text, instead of saying new text, we want it to say score :0, because that's going to be what it ends up saying here. The font size should not be -99. We should have it be perhaps maybe 30. And then let's take a look at where our score text is at here. So it's in the bottom corner for some reason to start. Let's go ahead and actually drag this up, and we'll put it in the top left here. And then let's see here. We don't have a font asset assigned. Oh, you know what? For whatever reason, it did not import our Text Mesh Pro essentials. So if it does that for you, we can go to Window here and Package Manager. And it should pop this up. And then I believe We should click on Unity registry first and then search text. No, it doesn't pop up there. Let me try creating another TM Pro and see if it uh, goes ahead and creates this for us. For whatever reason, it is not actually auto generating the thing. Let me look into this really quick, and I will be back in just a second. Okay, well, my TMP importer actually just appeared as I was looking at stuff, but if you need to, if yours does not pop up, you can go to Window, Text Mesh Pro here, and then just import TMP essential resources here. So you can just automatically do that, but we want to install this because otherwise, as you can see, our text is not going to show up. So we need it. We don't need examples and extras, so we can exit out. And you can see our score text is showing up now. So it's a little bit small. Why don't we make that like 40, maybe even like 50 even, just to make it a bit bigger here. So perfect, that works. In Scene Controller, we do need to drag score text into our score label here. So that looks all good there. And then I'm just making sure that I'm not missing anything. Yep, that looks good. And then the last thing we want to do, if we go into our scene controller, at the top, we can use using, and then we're going to say Unity Engine dot scene management. Okay, and this is how we're going to be able to restart our game. So we're just going to create a variable down at the bottom, or not a variable, a method, excuse me. It'll be a public void called restart game. And we're simply just going to write scene manager, and then we're going to say dot load scene, and then in parentheses we will pass in scene manager dot get active scene. So it's getting our currently active scene, and then we'll say dot build index, and then we close parentheses and a semicolon at the end. And this line basically just gets our active scene. It gets the active scene's build index, and it loads that scene. So it restarts the current scene that we're in, which is all we want for this game. We do need a button set up so that we can actually do that. I'm going to right click and create a button text mesh pro. For the source image, we can go ahead and if we go into here, we can go ahead and click and drag the start button into it. And then you probably want to resize it so it doesn't look all squashed. But we can resize it to say start here. We don't actually need the text element on it since it says start itself. And then we can just, scale it up, and we'll move it. This will be our restart button. So we'll just put it up in the top right over here. It doesn't have to be perfect. But the main thing is on the button, we need to go down to on click and click this plus. We're going to drag in our scene controller object here. And then where it says no function, go down to scene controller. And then we want to find the restart game method here. And what this does is when we click the button, it will call this restart game method for us. So let's go ahead and actually test all of this and make sure that it is, functioning properly. So we're going to play the game. And once it finishes loading, you can see we have our start button. And when you hover over it, you can see that it does change color. So it's clickable. We have a score here, and let's try and do some memory matching. So you can see we had time to look. This is a heart and a square. We found our hearts. The score goes up by 1, and these don't flip over. If we keep looking around here, we've got our diamonds, our score is 2. We have our crescents, and then we have our squares, and the score is 4. And then if we go click start, our scene reloads, our score resets, and we're able to play again. So you can see that it is mixing everything up. We have different positions for everything here. Again, if we restart it, different positions still. You can see that if I try to click a bunch of things at once, it doesn't let me click more than 2 at once. Okay. So yeah, everything is working great with it. So the only thing is, if you want to, you can adjust your grid so that it is actually more centered, or you can move the camera so it's more centered around where the grid spawns in. Um, so just to summarize our lecture for the week, this week we cover a lot of 2D game development in Unity 6.4. The book is, again, not in Unity 6.4, so some things may be a little outdated, but is still very good information. We learned about creating and using prefabs. We learned how to use arrays and generate grids of game objects, right? We looked at detecting mouse input, and we also did a little bit of scene management and restarting a game. So that is all for the lecture this week. Hopefully you are able to get a little bit comfortable with 2D game development. I find that 2D game development is a little bit simpler and easier since it takes out that third dimension. And perhaps you feel that way as well. So make sure you also go through creating this game yourself, because it is more helpful than only watching me do it. And I will see you guys in the next one.